Now, today's topic is differentiation, and this is one of the application of differentiation. So this number has been got from this book, and this is Pure Mathematics 1 by J.K. Backhouse. Now, what is on the whiteboard is a matchbox which is rectangular in form, ABEFDC, and the total perimeter or the total length around this matchbox is exactly 12 centimeters. Now, the question is asking us to find the maximum possible cross-sectional area, and the answer behind the book is 6 centimeters squared. Let's work hard together to find 6 centimeters squared. We are finding the maximum possible cross-sectional area. Now, let us remind ourselves, what is the area of a rectangle? So the area of a rectangle is actually length times width. Now, we don't have the length, we don't have the width. So let's say the width is x and the length is y. This is what is going to happen. This matchbox has this extension, it will also be x, but has EF, which will also be x, and has DE, which will be y. Now, let's try to add everything and we equate to the perimeter. So, x plus x is 2x. Now, if we add that to x plus y, okay, let us say x plus x plus x is 3x. Y plus y is 2y. So that is the perimeter, which is the total distance around the matchbox. So that is 3x plus 2y, and that distance is given here as the perimeter, which is 12. So let's try to make y the subject of the formula here. So if we leave y on one side, we shall have 12 on the other side minus 3x. So minus 3x, and then we divide everything by 2. So we shall be getting y as 12 divided by 2, which is 6, minus 3 divided by 2, which is 1.5x. So this is the value of y. Now, let's have our area formula. So we said area is length times width. What is the length? The length is y. What is the equation for y? So the y is 6 minus 1.5x times the w. What is the width? The width is x. So times x. So the formula for area will now be 6x minus 1.5x squared. This is the formula for area. So now, when we find maximum area, that happens when the derivative of area dA with respect to x is equal to 0. So the derivative is actually the derivative of 6x, which will give us 6, minus the derivative of 1.5x squared, which will give us 3x. So this must be equal to 0 for us to get the maximum value of area in question. So we equate this to 0. So when we equate this to 0, the 3x will come this side to make 3x is equal to 6. So when we divide by 3, both sides, we shall get x as 2 centimeters. And from this equation, we need to get y. Let's see what we have as y. Now, if x is 2, we only have to put it here as 2. So 1.5 times 2 becomes 3. So 6 minus 3 is the y. And 6 minus 3 is 3. So y is 3 units. So the area will automatically be length times width, which is x times y. But the x is 2, so which is 2 times, and the y is 3, which is times 3, and that will give us a 6 centimeters squared. This is the application of differentiation from the book Backhouse. Till we meet again tomorrow, we've got the answer today, and we are the heroes of the day.